Before we move on to number 4 at the bottom of page 5 on the 5.5 notes, I wanted to pick out in between videos the two that were most like the test. There's actually 3 on the test, but one's from another page. So 2 of the 3 are on this page, and I picked 1 and 2 as the 2 that are most similar to the test. I mean, I think they're all a lot alike, so any of them are good to study, but those are the 2 that I picked that were closest. Since this is such a big topic in Chapter 5, 9 of our test questions revolve around Section 5.5. I think it would be good if you guys tried the last 2 on your own. And I do want to give you a hint. I know it's kind of a spoiler alert, but I want to give you a hint about 4 so you don't do a whole bunch of work and then find out, you're on the wrong track. These have nothing in common. So the LCD is both of them. That's the first hint I want to give you. The second hint, before you turn off the video and work on 4 and 5 on the next page, is you have to multiply 1 by the LCD too. So if the LCD is x plus 4, x minus 4, you have to multiply it by this fraction, by the 1, and this fraction. Because what a lot of students do, there's a word problem that's set up like this on the test, is they skip 1. They go, oh, well, I'm going to multiply it by the 2 fractions. Oh, 1 doesn't matter. Not a choice. It's every single term gets multiplied by the LCD or none at all. So we need to make sure we multiply all of them. So go ahead, shut off the video, and then when you come back, we'll check 4 and 5 together. So number 4 on this page, number 5 on the next page. Okay, as we discussed earlier, the LCD is write everything you see, so we need it to be x minus 4 and x plus 4. And 1's denominator is just 1, so we can ignore it. So both of those are the LCD because they do not have anything in common. So they are both the LCD. I'm brightening it up a little bit. It's a little dark in here. And notice I rewrote it. I left some room there because we need to write that LCD beside every single term. So if it's a fraction, like I said, make sure you write it in the numerator so that you remind yourself to cancel. If it's a whole number, you just write it right beside. And another fraction, so write it in the numerator. So LCD is write everything you see without repeating. I see an x minus 4 and I see an x plus 4. So next we cancel. We always cancel before we start multiplying because remember we need to get rid of the fractions. And then this is just going to be 1 time those. So I think you know that the 1 can be just gone. It's just a FOIL problem. We can ignore the 1. And then here, the x plus 4 divided by x plus 4 is 1, so we're just left with that. So it's looking like 7 times x plus 4 equals 1 times x minus 4, x plus 4. And like I said, you can really just drop the 1 because 1 times anything is just that. So we can just get rid of it. And then this is going to be plus 9 times x minus 4. So here's my new problem. Notice I do not have any fractions, so I went from here to here and got rid of my fractions. I did just remember one thing I forgot, though, is to do my restrictions. So let's go over here and do the restrictions. So x cannot equal positive 4 because 4 minus 4 is 0. And x cannot equal negative 4 because negative 4 plus 4 is 0. So again, just so you don't forget, like I said earlier, I would definitely highlight that so you don't forget to look at it because like I said, I put 3 of these on the test and one of the 3 has solutions that are in the restriction box. So you don't want to forget 1, to write it, and 2, to highlight it so you remember to go back. So this is going to be 7x plus 28 equals, now this is a FOIL problem. So the 1, like I said, 1 times anything is that other thing. So that's why I got rid of the 1, but we do have to FOIL. So x squared plus 4x minus 4x, which as you can see are going to cancel. So outer plus 4x, inner minus 4x, last negative 16. And then plus 9x minus 36. So combine like terms, move all your x's to the left, and you will be done. So 4x minus 4x is gone. This side, nothing's common. This side, we do have like terms right here. So because of the x squared, we are going to have to set it equal to 0. So these are eventually going to have to come over, but I'm going to flip it on the next step. So this is going to be x squared plus 9x. So x squared plus 9x, what's that? Minus 52, I think. Negative 16, negative 36. Negative 16 minus 36 is negative 52. So equals x squared. Oh, gee, wow. Kim. Okay, let's start this line again. Too many videos again today, I think. So we have x squared. And then we have plus 9x. And then we have minus 52 equals 7x plus 28. Okay, so I took the right-hand side, x squared, those two canceled, plus 9x minus 52, and I put it on the left. I didn't move them, I just flip-flopped the equation, equals 7x plus 28. Now this tells me, we learned this in chapter 4, that I need to set it equal to 0. I cannot solve until it's set equal to 0. So that means minus 7x, because all the x's need to move left, and all the numbers, minus 28, minus 28. So that's going to leave me with x squared plus 2x minus 1080 equals 0. So now we have a regular quadratic function we learned in chapter 4, section 4.8. First you set it equal to 0, then you factor. Factors of 80 that subtract to 2 would be 10 and 8. And this says the signs are different. And this says make sure the largest one's plus. So 10's plus, 8's minus. And remember, do that little trick that I showed you. 10 minus 8, positive 2. Check your signs. You don't want to do all this work and then miss it because you got your signs wrong. So x plus 10, x minus 8. Then the other thing we learned in chapter 4 is if a times b equals 0, either a is 0 or b is 0. So now I think you're getting an idea why I told you chapter 4 is our most important chapter. Think how many times we've factored and how many times we've solved a quadratic in this chapter. Like about 150 times. So I don't lie. So x equals negative 10. Let's put that over here. Or plus 8 plus 8. X equals 8. And then before I put those in solution sets, I have to look up here. Are either in the restriction box? Nope. So we are good to go. So our solutions are going to be negative 10 and positive 8. Woohoo! That one was a little bit harder than some of them, I think. But it was a nice one, good practice, easy to find the LCD, easy to solve, just a little bit longer. I like it. Okay, let's do number 5. I hope you already tried it on your own because I think these are really good practice for you. This one is also very similar to the test because the test requires factoring, and then it has 3 fractions just like this. So let's highlight this one too. This is a really good one to study. And I know the test has numbers in the restriction box, and I think this one does too, if I remember from past semesters. So yeah, this is a good one to study, definitely. Okay, so we are ready to start. So I noticed that one of the denominators can be factored, so we have to do that first. So we're going to do 1 over x plus 6 plus 4 over x plus 5 equals -1 over, and we need to factor this so that we can get the LCD and so that we can get the restrictions. So factors of 30 that add to 11, 6 and 5. So x plus 6, x plus 5, because it's all plus signs. So now it's pretty easy to tell what the LCD is, right? Write everything you see without repeating. I see an x plus 6 and I see an x plus 5. So the least common denominator, x plus 6, x plus 5. And our restriction box, let's put that up here. X cannot equal, so what makes this 0? -6. What makes this 0? -5. And same here. Maybe we better use a different color highlighter. Oh, I think I got a blue here, just because we already used yellow. So if -6 or -5 is one of the solutions, we have to throw it out. Okay, so we need to put x plus 6 and x plus 5 in every single numerator, or beside every single whole number in this problem. There doesn't happen to be any. They're all 3 fractions, so write it beside every numerator. And remember, before you do anything else, cancel. Otherwise, you're going to do unnecessary work. X plus 5 divided by x plus 5, 1. And look at this. Woohoo! 1, 1. So all we have left is -1 over there. So -1 times 1 times 1 is just -1. Wow, this is going to be a sweet, easy problem. So what do we have left? We have 1 times x plus 5 plus 4 times x plus 6 equals just -1. Look at that. We took that big, ugly problem and look what it's simplified to. Beautiful. Beautiful. So let's solve this. 1x plus 5, and I'm going to keep the 1 in front of the x for now because I can see there's like terms coming up, plus 4x plus 24 equals -1. So 5x plus 29 equals -1 because we have like terms here, 1x and positive 4x, and then positive 5, positive 24. And then we're solving for x. This one does not require that we set it equal to 0. Notice there's no x squared. So we get 5x equals -30. Divide by 5, divide by 5. X equals -6. Uh-oh, whoops. X can't equal -6, so guess what I write? No solution. And Alex may want you to write it like that. It may want you to write it like this, or it may want you to write no solution. So just look and see what your choices are. Can't use any of them